Okay, so now we're finally in chapter 5, and we're going to be going over more on classes. So let's get into it. Chapter 5, 5.1. So now let's get back into the curriculum. In 5.1, customizing fields. In the previous chapter, we used fields to store data within a class, and we explored how to access and modify the values of those fields. Now, we will explore several ways to configure fields based on their intended uses. 5.1.1 Final fields. A final field is one that cannot be changed once it is initialized. This means slightly different things for primitive and class types. We create final fields by declaring them with a final keyword. We cannot change the value of a final primitive field, final, int, final double, etc., after it is initialized. Similarly, we cannot assign a new object to a final object field, final string, final double, final class name, etc. After initialization, however, we can change the values within the object itself. Here are some examples to illustrate. Each class will normally be in its own field, but we present them side by side for convenience. Additionally, we declare each field public to minimize the example code and more clearly demonstrate where compiler errors will occur. Okay, so let's look at this here. So we have a class right here called 42. So what I want to do is let's go ahead and let's open up our IntelliJ. Let's create this class. So here we have a new project. I'm going to create a new project. And in this project, I'm going to call it Chapter 5. Because it's important that you practice and play around with the code. So I'm going to create everything. All my settings is correct. So I'm going to create this. Okay, so now what I have is chapter 5, and I have my source and I have my main. But what I'm going to do here, let me close that. So if I look in my main, open up the main here, and I have a main and I have the static void here. Now, I can use this as a final field, but what I'm going to do is create a new class. So I'm going to create this class right here, and we're going to call it Java. Go to Java class, and we're going to call this 42. Now, understand that I am capitalizing, I'm using Pascal case for our classes. So that means the first letter is capitalized. And inside of here, I am going to create a public class or a public field. So I'm going to call it public and initial value, right? And I'm going to initialize that at 42. So I'm signing it to the number 42. Now, this is public. Now, normally, like we said in the instructions, we always separate our classes. But in demonstration purposes, we're going to put them in the same exact file here, which is right now the 42 Java. So here, as I do, I create a public. All right, so I'm going to create public, and I'm going to call this class final. We're going to call this final field. So the final field class here, it's going to have inside of it 3 different fields here. And let's go over each one. I'm going to copy them just for time's sake and paste them in. So inside of my class, I have these fields. I have these objects here, and I have the final initial int for init value, which is 42. And we have this up here in the 42 class at the top, right? But down I have a public final double, and I'm just declaring it. I'm not initializing it yet. So there is no value to it. And then I have a public final 42, and I'm calling that particular object value. And then I'm going to assign it a new instance of the 42 class. Now, again here, because in order for us to run our code, we have to have a main. So I'm going to copy all of this code right here, just like I said, for demonstration purposes and save you some agony and not watching me type this. So as you can see, I have the play button here. Now, as I look through the code, let me close this to make this bigger. I see that in my public main void, I have a final field and I'm calling it demo. And now I'm initializing it with the final field class, which is this right here. And so with that being said, as I go down and I look at my demo and I get the initial value of 6. And then the demo double value of 42. Now, the thing about we have to understand, let's read a little bit further here. It said final fields help to prevent accidentally or intentionally changing the value of a field after it is initialized. As such, final fields may not have setters. Now, I'm hoping that that makes sense with these getters and setters. Think like the compiler. When you see a final on a field or an object, you will not assign it a setter. You may do a getter, but you will not assign it a setter. And that's where we go back to encapsulation. So one of the things I want you to make sure you practice as you go through writing your code is to say what type of or what principle you're using in this particular part of your code. So now as I go back into my code, I notice here that I have these fields right here. This will result in a compiler error. We know that's going to be a compiler error. Why? Because initial value is set to final up here. So we know that's going to give us a compile error. This is allowed since we haven't initialized double value yet. So the reason why I'm able to initialize 42.0 is because double value is not initialized. We just declared it. So pay attention to these little small subtle differences. But then when I go down and try to assign it another value like 6, I'm going to get an error. Now this one says this will result in a compile error since we're trying to give object value a different object value. So I am trying to assign object value to new 42 instance. So my object value right here that we assigned it to 42 object value 42. And what it's saying here, you're trying to reassign it again because here we have that demo. We created that demo, final field demo, and demo is a new final field. We can get this from the final field, but what we're trying to do is reassign object value, demo.object value by giving it 42. So we're basically saying we're trying to do this twice when we've already declared it once. However, this is allowed since we're changing a field inside the final object and not changing which objective value refers to. So if I do demo.objective value.initial value and then change this to 6, then this is said this is going to be allowed. Now, this is one of those things that you're going to definitely have to play around with to really get your head around it. But again, don't get stuck here. Remember to always go through the whole entire chapter and then come down and play with each section. But even still then, don't get stuck. Keep moving forward and then get to the exercise and then go back and review again. And then even if you still don't get it, don't stay there. Keep moving to the next chapter because eventually what's going to happen, it's going to click. The more and more you practice, the more you're going to improve. Remember? Now here in 5.1.2, static fields. A static field is one that is shared by all instances of the class and is declared with the static keyword. So we're getting into understanding what that static means. For example, In our temperature class, there is no reason for each temperature object to hold its own copy of the double absolute 0 Fahrenheit. That value remains constant from class to class and object to object. Because of this, we make it a static field. Because why? Because it's constant. That means it's not going to change. It's going to be the same thing across every class, across every time you have an instance of it. So therefore, we can make it static. So a big process of understanding how to program is when and where to use certain things. Understanding the rules and the principles, that takes time. But the more you practice it and play around with it, the more it'll make sense. So here, previous examples used the static keyword with both fields and methods. But since this discussion is focused on data, let's focus on static fields for now. So here we have the temperature class. And here we have a private double, Fahrenheit, private static double, absolute 0 Fahrenheit, which is negative 459.67. Public double. So now here we have the get Fahrenheit. We know that this is a method and that it is not a constructor because it's not, it has to be named. The constructor has to have the same name as a class. So we know that this is a method on line 7. And then it's going to return the Fahrenheit, which is a private double. So this only has access to this class. Now, we have another public void set Fahrenheit. Now, we can use a setter here. We have getters and we have setter. These are both methods. We can have a setter. Why? Because we don't have the final keyword here. So we can set this if we want to. But the thing about it is, let's keep going forward as we look through the code here. If the A Fahrenheit, notice that we put the A so we don't have to worry about shadowing because we're using the same name as Fahrenheit as this field. So we have to put the A in front of it. So it makes it a totally different variable. So if A Fahrenheit is less than absolute 0 Fahrenheit, throw new illegal argument exception. We're throwing this method in. This is a method that we're getting access to, or a class we're getting access to because of the new keyword. And it says value is below absolute 0. So therefore, if I try to make it less, if I create that new variable A Fahrenheit, and I try to make it less than negative 459.67, it's going to throw an error. So this if conditional is what we call a check. So we're checking to make sure that everything is correct. You do that in your code. You put checks in so that you are able to control the data flow in your project. If I don't have this check in here, then I will get some type of error and I won't know why. So this is just to let me know that, okay, this is an error that I put or a check that I put in my code to make sure everything is working as intended. So there are multiple ways to refer to a static field. Within a class, we have the system out print line. And it says use a static field the same way as a normal non-static field. And so we're printing out absolute 0 is F is plus absolute 0 Fahrenheit. So we're concatenating that, right? So, or we got the system dot print line absolute 0 is F is this dot absolute Fahrenheit, absolute 0 Fahrenheit. Okay. So we're naming that object when we use the this. We know that we're dealing with this particular object right here. So remember that is still an object. Now, outside of the class, this is what we do within the class, but outside of the class, we do the same thing, but we have to append the temperature, and then we call the actual object right here, which is absolute 0 Fahrenheit. And then if we created another type called temp, we would do the exact same thing here. So this is for demonstration purposes. Now, when assessing a field from outside of its class, the line 7 shows the preferred technique. That's on line 7. The syntax makes it explicit that the field is static. Line 10 does not make this point clear. So this is not making it clear for us, right? Up here on line 7 is clear because we know that this is a part of the class. This is right here not clear because temp, it says, or if we have an object named temp of type temperature. Now, here's an example. As another example, we might also provide a third constructor for our student class that only requires the student's name. Theoretically, the student ID would or could be generated by the class itself. So here we go. We have the student class, and we actually created these projects. If I go over here and I close out this project and I come over here and then if I come over here and I go to I think it's this one right here, and we have array grade book. It might even be, I think we have that. I had created those separate. I don't think I have the students in this one. Let me go back and let's see. Let me close this one real quick. I think this is the one where I did that student. Yeah, here we go. So I created that student class here. But let's look at the example again. So here we have the private static int next student ID. Now, the whole point of this is we're talking about we adding an extra constructor. How do I know that these are constructors? Because the constructor has the same name as the class. And we're doing constructor overloading here because we have different use cases. Now, in line 3, we add a static integer on line 3. So here on line 3, we add static int student ID 1. So this is going to be the same across all of these particular constructors. So if I have the next student ID is because it's the counter starting at 1, because you're not going to start a student ID at 0. You're going to start it at 1, and we're going to add there every time we add a student ID or the next student ID. Now we add a static integer field that will keep track of the next student ID to be assigned to a student. Then our new constructor, line 21, on line 21 right here, takes only a name as a parameter. Notice that it has just the name. And because if this is a new student, because we just got the name, then it'll add the next student ID for us inside of this. And this is another way of using this for the particular fields or objects that we want to access. Now, assigning the student the next available ID. This works because static fields are shared across all objects created from the student class. So it functions as a counter of sorts for the number of student objects created. Again, it functions as an counter. The next student ID, this is why we did not have to pass it in as a parameter. We just need the name because the name is a new student. Okay, and where are we getting this from? We're getting it from up here when we created this variable right here, or we declared it without initializing it, and we're able to have access to those particular objects. Because remember, all of your fields, your objects will be declared at the initial, or at least declared at the top of the class. Best practices, by the way. 5.1.3 constants. Unlike some of their other languages, Java does not have a special keyword to declare a constant or unchanging variables. However, we can achieve the same result using a combination of static and final. Here we go. So we have static final double pi. So this cannot change. This is constant. And then we have the public static final string first underscore president. We know that in the United States, the first president is George Washington. No one else can be the first president. So that means it won't change. It's immutable. Throughout the rest of this course, when we say constants, we will mean a static final variable. Key, remember this. Whenever we say this, think like the compiler. We mean for it to be a constant. 3 things to note from this example. 1, when we use a different naming convention for constants than for other variables. Constants should be in all caps. Yes. Pay attention to that. Constant should always be in all caps because that's a convention that we follow in order for us to know what we're looking at as developers. So if I hand you over my code and I follow these rules and I follow these standards, you'll be able to work more efficiently as well. But if we all had different standards, if we all had different rules, it would be very confusing. So remember, all constants have capital letters. And so whenever you see capital letters, all caps for your constants with an underscore, because you're going to use an underscore to separate the words because there is no way to distinguish between the two unless you have the underscore. You're going to see that in a lot of your programs when you go work at different companies, that when you see all caps with the underscore, that's a constant, meaning you know it's not going to change. Now, 2, there is a strong reason to make constants private, since restricting access will force to redeclare the same values in different classes. We generally make our constants public. We must declare and initialize a constant at the same time. If we do not declare and initialize a constant in the same statement, we cannot assign it a value later. The constant's value remains empty. A good use of a constant can be seen in the temperature class. Since absolute 0 will never change, we can ensure that nobody ever alters it intentionally or by mistake by adding final to make it a constant. As you can see right here, we know that this is a constant. Reference, declaring members. So go through these references and check your understanding. Okay, so we made it to the end of part 5.1. So again, don't stay here, finish the chapter before you get to the exercise, and then come back and go through it more. Take your time going through it and understanding. But once you get to the end of it the second time, then do your exercise and then go, and then, because you know what you can reference. And remember, your exercises may depend on what you've already learned up in chapter 4 and chapter 3 and chapter 1. So you have a good sense of what's there up until this point. So that's the end of this video. Remember, the more you practice, the more you improve. All right, see you in the next one.